Recordings rolling. It is Tuesday, September 9. So you guys know yesterday we did lesson 1.5a, which was piecewise functions. So today we're going to go into 1.5, which is separate, and that's the absolute value functions, right? Which look kind of like, you guys see these absolute value bars, right? So I wonder what that function would look like. If you guys have your notes out, about to find out pretty soon how you guys draw that. Right. So what's going on in terms of Alex? So uh, you guys know on Sunday I opened this up.
I go get my laptop over from that computer.
So 1.5a, 1.5, which is yesterday and today, and then 1.6, which we're going to cover tomorrow in class. Okay, so that's been open for a few days on Alex, and from now on we're just going to do Alex Alex for homework. Right, so if you're saying that was a better idea. Okay, now 1.1, 1.2, and 1.3. This is the one that you guys did on paper. So yesterday I scored those and I put those back in their folder, so you guys have those back. Oh, I did get a request to also open up the Alex version. So I went ahead and did that, but I'm not going to square it. These guys did that on paper already. So the paper one is the grade for 1.1, 1.2, and 1.3. But if you want to see what does the computer questions look like, then those are available. So they can just be extra practice if you like. And my plan is to have Thursday be an Alex day, so you can work on either these homework puzzles on Thursday or just your general pie on Thursday. And then Friday's going to be Module 1 quiz. So Module 1 covers 1.1 through 1.6. All right. All right, so you guys see with agenda, what we're doing? Yeah, all right, so you guys write your planner, do Alex homework, although I'll give you guys Thursday anyway. All right, so where are we here? So yesterday we were here doing these piecewise functions. So here's yesterday. Yesterday was piecewise on page 43. So we did that already, did that. All right, we are up to page 47, absolute value functions, absolute value, page 47. You guys are on page 47, absolute value. So I'll do as many examples in class as I can with you guys. And then when you guys do the Alex homework version, then this all makes sense. Okay? So let's start with real basic. I'll say f of x, like a function, equals just very simply absolute value of x. Okay, just that right there. And let's come up with a graph for this. So x-axis, y-axis. Okay, so go ahead, make that graph. I'm going to walk around class, so I'm curious to see how many of you guys know what that actually looks like. Maybe you do, maybe you don't. Maybe you can figure it out. F of x is absolute value of x. It's just very, very fundamental. What's that going to look like? Absolute value of x? Oh, yeah, so 0, will be a point, wouldn't it? Yeah, if you plug in 0 for x, you get 0 for f of x. So that's 1 point. But there's lots of other points. I know. They can use that so much.
I'm so very. I have Boston.
Oh, here. Oh, wait, no. I said a question. I think it was really good.
So, guys, if you ever don't know what a graph looks like, can you make an XY table and just come up with a bunch of points and just plot the points and then maybe the graph emerges? Let's try -2, -1, 0, 1, 2. Okay, something like that. Let's see what happens. So if you plug in -2 for this x, guess what's the absolute value of -2? Yeah, 2. Okay, what's the absolute value of -1? 1. Absolute value 0.
Yeah.
0. What if you plug in 1?
1.
1. What if you plug in 2? 2. Right. So these would be 5 points. Okay, let's plot this. So, okay, so 0, 0 is going to be a point. It's right there. Got -1, 1. -2, 2. About 1, 1. 2, 2. Okay. Now, I could keep going, but do you guys see what shape that's going to be? Like if I connect all the dots, it makes a what shape? It's a V shape. You see that V shape? Right? Like, guys, if x is positive, the absolute value of x would just be x. It's not just y equals x. And if x is negative, well, it just negates the negative and makes it positive. So it's like negative x is like that. Is that? Actually, speaking of that, let's make a piecewise out of this. Isn't that what we were doing yesterday? Piecewise? Let's make a piecewise function. Piecewise, because you can actually describe an absolute value graph as a piecewise. Because it's kind of like there's two halves of the story. There's the left half of the story and there's the right half of the story. So let's put it that way. Let's do f of x. This will be the same thing. Equals. Then open up like one of these curly brackets, and we're going to come up with two separate functions. So, and each function will apply to a different domain. Guys remember that? F of x equals something if x, in some domain. And okay. So let's start with this left side. Guys, what's the equation of just that part of the graph? What is that? Does anybody know this equation?
Y equals negative
Negative x. Yeah, negative x. Guys, isn't this like y equals mx plus b?
Yeah.
But the plus b is just 0. And guys, what's the slope right here? It's negative 1, right? Isn't the slope like down 1 over 1, down 1 over 1? Right. So is it just negative x? Okay. Okay. Now, since this is a piecewise, this is only true if x is what? That only works for less than 0. Yeah, less than 0. As long as x is negative, like the left side of the graph, then y equals negative x. Right? But there's another half to the story. Are you guys okay with this so far? Look at this. Okay. Any questions? Okay. Let's do the right side of this. So what's the equation of this line right here?
X.
Yeah, y equals x. Just very simple, y equals x. Right.
X is greater than
Yeah, if x is greater than 0. Okay. Okay. Now one more detail. What if x is equal to 0? There definitely is a point here, right? Okay. So you have to change one of these inequalities to like or equal to also. Okay. I'll do that on one we just did. I'll say greater than or equal to. Okay. It doesn't really matter. It's either one or the other. You type it to one or the other. Okay. But it's a good practice to not type the equal sign to both, because then you might possibly accidentally fail the vertical line test. Okay. So you guys kind of with why this function right here, f of x equals absolute value of x, and this piecewise we just put together are exactly the same thing. Okay, so these two are exactly the same thing. You see that? Okay, and let's go back to the book, see where we are in the book. But hey, that's what we just made right there. Look, it's that V graph. That's the V. That's the V. Oh yeah. So what do they have to say about this? They say absolute value function. It's an algebraic range expression with absolute value symbols, those vertical bars. They're often used to model situations where a value is constrained to be non-negative, right? Like there's some word puzzles eventually in the book that have to do with like the distance from some location. Like you go to the left location, the right location, but your distance, right? This is page 47. Yeah, 47. For an absolute value function, f of x is the absolute value of x, which is what we just graphed, which is that graph right there, is called a parent function, which is the simplest of the functions within a family. So later today, you'll see this, and also tomorrow. Actually, what we do today is kind of a launch pad to tomorrow when we're doing transformations. You can stretch this vertically. You can stretch or squash this horizontally. You can slide this to the right or the left. You can slide this up and down. You can create all different type looking graph. Like this one down here. You guys see this graph start off looking like absolute value of x, but the whole thing is slide up. Also, I don't think that slope is 1-to-1 anymore. I think it's more like, isn't it like stretched horizontally or squashed vertically? I think either way. Right? You guys see that too? Okay. Actually, let's look at that while we're got this right here, same page. They list the function right here. They say f of x is, and then in absolute value bars, we got 3/4 x. And then outside the absolute values, we've got a +3. Okay. And you guys know what it's going to look like because they give it to you right here. Okay. So what's the relationship between, or like, what's the connection? Like if you just saw this, how would you know immediately it has to look like that? Let's do this in terms of transformations, and we'll make a table, and then we'll put this together and guarantee that, yeah, it's true, right? So, guys, in terms of transformations, and you might know this, you might be able to figure this out. Let's start with this +3. Because what does this +3 at the end of the function tell you to do to the function?
I'll build it up 3.
Yeah, move it up 3. That's it. It's just vertically up 3. That's all. That's not too bad, right? That's fine. Okay. Now, this 3/4, there's actually 2 interpretations. And they both end up, of course, doing the same thing, no matter how you interpret it. Okay. Because what's one interpretation of 3/4? Could I do this? Because could I take the 3/4 outside the absolute value and it wouldn't actually change the function? I could do. Could I do this? Could I do 3/4 and then times and then absolute value of x and then the whole thing plus 3? Would this in this map to exactly the same function?
Yep.
Yeah, they would, right? Right. And actually, in terms of this, then here, maybe I'll just label this one this way. Okay. Does this vertically smash the whole thing by 3/4? Okay. So I'll call this like a vertical. Well, I'll write it this way: stretch or smash. Okay, so we're like vertically stretching it. It's times the factor of 3/4 in this case. Right. So if you vertically stretch by 3/4, 3/4 is less than 1, so you're actually smashing it down, right? You're making like 3/4 the height overall. Right. But there's a different interpretation. If you actually attach the 3/4 directly to the x, you can actually think of it not in terms of a vertical transformation or a stretch, but in terms of a horizontal stretch. Right. So this could be a horizontal stretch times. Okay, so here's where things get tricky. Are you guys ready for this? You guys ready for this? Right. Horizontally, everything's sort of backwards of your intuition. So this doesn't stretch it horizontally by 3/4. It stretches it horizontally by what's the reciprocal of that? 4/3. 4/3. Okay. Here, I want you guys to see if this is true because they give the answer right here. Look at the answer. You guys know it's this graph, right? Okay. If this was just plain absolute value of x, let's say plus 3. Let's slide up 3. Okay. Then you guys see these lines would be a little steeper than they actually are. A little steeper. Right. And if you smash it vertically by 3/4, that would smash it down to exactly what's shown. So that works. Right. Or alternatively, if you go back to just the plain absolute value, you stretch it by 4/3. You see that also aligns exactly with that graph. You see it's the same thing. Okay. Right. So here, let's make our own graph to just guarantee it. They're not lying to us, right? Okay. So get a graph going. Got x, y, go. So let's do an XY table. So x, y, come with some values, see what happens. So what if x is 0? What if x is here? Throw in another point here. So let's go 2, 4, and then -2. Okay. I think that'll be just enough points where it'll be really clear what the graph's going to look like. So you guys know this. We're using this whole function right here, the whole thing, the whole enchilada. Plug in 0. Because if you plug in 0, what's 3/4 times 0? 0, and then plus 3 gives you 3. So the point 0, 3 definitely exists. Right there. There's the point 0, 3. So that's on the board. That's good. Okay. Let's plug in 2. Guys, what's 3/4 times 2? 3/4 times 2. Is that saying times 2 over 1? This is 2. 3 over 2. Is that like 1.5? Right, 1.5. Right. Okay. So we have 1.5 here. Absolute value 1.5 is 1, so 1.5 plus 3 gives me what? 4.5. Aha! You guys get that? Okay. All right, let's do 2 more of these. So if you plug in 4, what's 3/4 of 4? 3. And then absolute value is still 3. Plus another 3 gives you 6. Ooh. And let's do -2. What if you plug in -2 in here? -1.5. Right? And what's the absolute value of that? It's back to positive. Positive 1.5. Okay. And then now 3, guys, what's this positive 1.5 plus 3? 4.5. Actually, I lied to you guys. Let's do one more. Let's do -4. So if you plug in -4 right here, guys, what's 3/4 of -4?
3.
-3. Okay, but then if you do the opposite value, then you get +3. And then you add this 3, you get 6. Okay, let's plot all 5 of these. And we've got one already. So let's do 2, comma 4.5. 2, 4.5 is right here. 2, comma 4.5. We've got 4, comma 6. That's right here. 4, comma 6. Okay. And then on the left side of this graph, -2, 4.5. And -4, 6. I have all the points. I did that right. 4, 6. Okay. Okay. Of course, we take 5 points, but we can take any of like a billion different points, and they're all going to lie on that line right there, or well, that function, that deeper. Right. Okay. And isn't that exactly what's shown in the book right here? Right. Make sure you guys are following. Guys, what is this slope right here? What's the slope equal to? Yeah, 3/4. 3/4. Right? Like if there's somebody walking uphill here, every 4 units he walks over, he has to walk up 3. So up 3/4, up 3/4. Okay. And what's this slope over here? Yeah, -3/4. Looks like that. Right? Okay. So again, that's where I'm going to tie this back to what I was showing you guys with transformations. This 3/4, you could interpret it as a vertical smash, like 3/4. Right? Or a horizontal stretch, but then you have to take the reciprocal. If you stretch it out by 4/3, it ends up being exactly the same thing. Okay. Starting from the parent function. All right. Let's do some more. You guys ready for the next page? Okay. All right. What else do I want to do here? Let's do. Oh, looks fun. Yeah. All right. Let's do this example. So example 2 on page 48. Example 2 on page 48. So I got f of x equals -2, and then in opposite values, I got x plus 1. Wait, that's the whole thing. Okay, just okay. Okay. It says state, domain, and range. So we'll draw the graph, and then we'll come up with a domain and a range. Okay, so get some axes going. Okay, x-axis, y-axis. Right there. Okay. All right, and then eventually we're going to come up with a domain. Okay, now let's do set builder notation. And then we'll do interval notation. Okay. And then same thing for range. We'll come up with a range. We'll do set builder and interval notations. Okay, so we'll come up with all this, right, for that function. Okay, you guys go with the premise. You guys got that all in your notes? On your notes. Okay. Okay. So there's a couple ways to graph this. One is if you know transformations, you can whip this off really fast. If you have no idea what this looks like, you could make an XY table and just start plotting a bunch of points, and eventually the graph emerges. Right? So let's start with the transformations. Guys, what do you think this -2 out in front of the whole function eventually does to the graph? Well, the fact that it's negative makes it what? Upside down. And the 2 stretches vertically by a factor of 2. Okay, so I'm going to say this is vertical flip. That just means upside down. Okay, and stretch by factor of 2. Okay, so it's going to be stretched by a factor of 2, and it's going to be upside down. That's from that -2 approach. Okay. All right. Guys, here's a little tricky one. You guys see this +1 right here? You guys see this +1? Oh, now is that a vertical or horizontal type motion? Horizontal. Yeah, because it's inside the absolute values. It's sort of attached to the x. Like if it was out here, if it was the whole thing, and the plus one was out here, now that would be a vertical motion of one. So it is horizontal. Now, remember I told you guys all the horizontal motions are sort of opposite of your intuition? What that means is if you see plus one, that really means you're going to shift which way one? To the right or to the left? Left. Yeah. Guys, this right here means go left 1 unit. Okay? Great. I'll show you this both ways to graph this. I'll show you guys from the transformations what I think the graph's going to look like, and then we'll make an XY table. We'll plot a bunch of points, and I guarantee you all the points we come up with are going to match this transformation. You guys ready for that? So you guys know the parent function. I'll dash off the parent function. The parent function is just y equals absolute value of x. I'm dashing it off right now. Right. This isn't part of the answer. I'm just using this as a starting point. Doesn't this dash off v, isn't that absolute value of x? Okay. So starting from that, let's flip it upside down. So now we got like an upside down v. Can you guys imagine an upside down v? Right. Let's stretch it by a factor of 2. So now it's like this. Now it looks like this, right? We went from here's just plain upside down to factor of 2. And then the whole thing, bonk, left 1. So the vertex should show up right here. That should be the vertex right there at -1, 0. And then I think, so somebody tell me, what's the y-intercept? What's the y-intercept? Here's the vertex. Where's the y-intercept? 0, -2. Yeah, exactly. Has to be right here. And then on the other side, okay, you guys see how this v is like twice as steep as the original v? Of course, also upside down. Okay. This should have a slope of 2/1. And this has a slope of -2/1. Okay? Okay. Now I got that out of transformations, which again is like tomorrow's main lesson. Okay. But let's come up with a bunch of points, because I'm making the claim here that, well, at least these 3 points exist, and I guess the point 1, -4 should exist. 1, -4. I'm getting 0, -2. And then the point -1, 0. And then this one over here is at -2, -2. Right. So there's 4 points that should show up. Let's test that. Let's make an XY table. I could have started with the XY table. -2, -1, 0, and 1. Right. And we should get all these y values that lie exactly on that upside down v. Okay? Right, you guys get that? Let's try it out. So let's go back to the original function. So what's -2 plus 1?
1, -1.
-1? What's the absolute value of -1? Yeah, 1 times -2 is -2. Right. So the point -2 should exist. Does it? Hey, it's right there. It's right there. Oh yeah. Oh yeah. Let's plug in -1 for x. Guess what's -1 plus 1? 0? Oh, okay, so the whole thing is just going to zero out, right? Okay, 0. So -1, 0. Hey! That's that point right there, which I'm claiming is the vertex. Let's see if that also emerges. Let's plug in 0. What's 0 plus 1? Absolute value 1 is 1 times -2 is -2. So the point 0, -2. Oh, should that be the y-intercept? Let's see if it is. Hey, it's right there. 0, -2. Oh yeah. Oh yeah. Right, you guys went in this too? Yes. Right, one more point I want to try. So 1. Because what's 1 plus 1? 2. Absolute value 2 is first 2. Times -2 is -4. So 1 -4. Let's see, is that a point? 1 -4. Oh yeah! It's right there! 1 -4. Oh yeah. Oh yeah. Right, so that makes sense. I got it. We still got to come up with domain and range in each of set builder and interval notation. So let's start with domain. Do you guys remember what set builder notation looks like? It starts off with a what?
Curly.
Yeah, a little curly bracket. A curly bracket. And then you go x such that x. Okay. Now, guys, look at that domain. Domain. Domain is possible x values, isn't it? Possible x values is domain. So what are the possible x values? Could it be anything? Could be anything, right? Yeah, all real numbers. So how do you write all real numbers here?
The E.
Yeah, there you go. Element of all real numbers, and then close the curly bracket. Right, so that's what. How do you write this in interval notation?
forgot. I looked it up.
So open parenthesis, negative infinity to infinity, close parenthesis.
I got it.
Okay. Now that's the domain. That's the domain right there. So that's the possible x values. Let's do the range. The range works out a little different. So set mode orientation. I got open curly bracket. I got y such that y. Right. Now here's where this deviates from what we did for domain. This works out a little different. Guys, can y be anything? Yeah. Can y be equal to 3? No. There's nothing up here. Guys, there's nothing up here. Y can only be what kind of values? Yeah, negative or 0. Right? You see it? Y can be negative, that's fine. Shows up down here. Y can be 0, that's fine. But it can't be anything above the x-axis. So how do you express that as a range? Less than or equal to 0, and then close curly bracket. Right? Will you guys be able to do that on the quiz on Friday?
Oh, I think so, yeah.
Surprise!
Failing.
Yeah. You guys got any plans for quiz Friday?
Oh, yeah.
Yeah, it was
Just the house.
it's in the guys, it's gonna be on all module 1. All module 1. How about interval notation? Interval notation.
Oh, you do the parentheses.
No, yeah. So open parenthesis, you can go all the way down to negative infinity. You can go down as far as you want. Okay. Comma
0.
0, and then finally you need to close this with a
Factor.
with square brackets. Yeah, because it's allowed to also be 0. That's why it's a square bracket, not a parenthesis. All right, we're getting this. All right, you guys get on that example? Yeah. All right. We'll do more. We'll do more. All right, let's keep going.
Yeah.
All right, what else we got? All right, let's keep going. No, I do want to do some of these word puzzles too. Do you guys want to do a word puzzle or an abstract question again?
Abstract.
Abstract. Let's do abstract again. How about number? Here, let's do 3 and 5, and then we'll hit one of these word questions. Oh, we got 23. Yeah, let's do 3 and 5. Number 3, we got h of x equals, and then in absolute values, we got 2x,
This African girl get there.
and then after that, minus 8. Okay. Oh, here, I'll do the same thing as I did with the last example. I want to think about this in terms of transformations, and then we'll check it with a bunch of points. Hey guys, this minus 8 tells you to do what to the parent function.
Take a little bit down.
Yeah, so down 8. Like vertical, down 8. Okay. Now, this 2 on the x could have one of 2 interpretations that end up being the same result either way. Guys, what's one interpretation of that 2? Could you pull a 2 out and make that like a vertical stretch of 2? Right. So you could say vertical stretch factor of 2. Well, say vertical stretch times 2. Right. Or horizontal, which is probably a better interpretation, strictly speaking, because it's inside the absolute values. Okay. Horizontally, does it squash it by a factor of 2? Horizontal, I'll say squash times 2, or you could say stretch times a half, right? Anyway, it ends up squashing it this way by a factor of 2, right? Or something like that. Yeah, it's opposite of your intuition. Like vertically, it would just stretch it factor 2, but horizontally, it squashes it. Okay. Of course, those end up being the same thing, right? It's like tomato. So, what's this look like on the? Okay, well, down 8, it definitely better go way to negative territory on this one. So let's get x-axis, y-axis, then.
How many countries are on the test?
I think there's 12.
Oh, one more choice?
Mostly, but not completely.
I'm gonna become graphically one.
Yeah, I think there's a graph question there.
Okay, that's fine.
Okay. All right, so it's based on the transformations that I just wrote in Pinky. I think I can get the whole thing. So you get my current function is absolute value of x. I'll dash that off just for reference. Okay, so this isn't the answer, but you guys know absolute value of x is that classic P right there. Okay. From there, if I shift it down 8, that pulls the vertex down to 0, -8. And then if I stretch it by a factor of 2 vertically, or if I squash it by a factor of 2 horizontally, either way, these lines would be twice as steep as the parent function. So shouldn't that Go like that. Like that. Okay. I think that should be the answer. So I'm making the claim that there's a point here at -8, comma. This is 0, comma -8. That's what it meant. 0, comma -8. Maybe it's the y value, whatever. I think there's a point at 4, comma 0, and I think there's another point at -4, comma 0. So those 3 points should show up. How about this? How about the point 2, -4? 2, -4. We'll test all those out. All right, guys, good? So let's make an XY table. Okay. Again, if you didn't feel comfortable with the transformations I did, you can just make a table and just start plugging in stuff. -4, 0, 2, 4. Because I guarantee you, we're going to get exactly the same function. Going to map exactly on that. So let's start with -4. Guys, what's 2 times -4? -8. What's the absolute value of -8? 8. And what is 8 minus 8? 0. -4. Hey, that's that point right there. Oh yeah. Oh yeah. It's fucking 0. 2 times 0 is minus 8 is -8. So 0, -8. Hey, there's this point here. About 2. 2 times 2 is 4. And absolute value of 4 is 4. Minus 8 is -4. So the point 2, comma -4. Let's say 2, -4. Hey, it's this guy right here. Oh yeah. And let's plug in 4. 2 times 4 is 8. Minus 8 is 0. Hey, it's this guy right here. Oh yeah. Hey, you see how all the points are lined? Right? Let's do number 5. So we're going to do number 5. Oh, and then we'll also do domain and range for number 5. So we'll do all that. Number 5. We got f of x is, okay, we got 2, and then in absolute values, we got x minus 4. And then outside of that, I got a plus 6. Right, let's go big on quadrant 2 on this one. So, or no, that's not right. Quadrant 1. I'm being silly. Or quadrant 1. So x, y, they do go like way up here. Yeah.
How do you know like how many you not like points you have to add?
Yeah, guys, how do I do to make the graph like this, right? Okay. Because actually that was my next question for you guys is what's happening with the transformation? Because I know the class of D starts at the origin out down here, but I'm making a guess this is going to shift to the right and up. And I need to do something with the right and up. Okay. Now, how do I know that? Like, guys, what does this plus 6 mean to do? Up 6. Yeah, up 6. Because it's outside, it's like tag at the end of the function. So that's why I know we got to have everything above the x-axis. It's going to be like way up here. Okay. Also, here's a tricky one. Here's a tricky one. What does this -4 do? Shifts it which way, how much? Right 4. Yeah, guys, this is right 4. See, it's inside the absolute values tagged to the x. That means it's a horizontal shift. Horizontal. And remember, horizontal is sort of opposite of your intuition. So if you see negative, that means you're going to the right. Yeah.
So for example, if it was -6, you'd be doing it 10 times like down instead of up.
Oh yeah, if this said -6.
Yeah.
Yeah, I would definitely want to go like way down here. Yeah. Okay. Okay, and there's one more transformation I'm looking at. You guys see this 2? That means to do what? Could that be a vertical stretch of 2? Yeah. So vertical stretch times 2. Okay. Okay, vertical stretch times 2. Okay. So starting with the parent function, absolute value of x looks kind of like this. Dash, 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 dash. Okay. There's my y equals absolute value of x. I should shift that to the right 4. That's right here. I need to go up 6. That's right here. Here's the point. 4, comma 6. I'm following the vertex. So I think my new vertex is going to be at 4, comma 6. After that, I have the V shape, except it's also stretched by a factor of 2. So factor 2. Will that give me a rise over run of like up 2 over 1, up 2 over 1, and so on? Let's see if I went down 6 over 3. Yeah, like this. Okay. So I think it's going to go like this. Is that up 2 over 1? This down. Oh, whoops, so that's not quite right. Goes like this. I got a little off. Okay, that's better. Okay, goes this way. And we're ready to do it. Right? And then, let's see, down 6 over 3. It's like this.
Okay, so is the 2 the slope?
Basically, yeah. Yeah. This is a slope of 2. This is a slope of 2 here. Yeah, because the vertical stretch of factor 2. Okay. Should look like that. Okay. Let's see if an XY table would agree with that. We'll just come up with some values. So what's going on at 0? Let's do 3, 4, and 5. 0, 3, 4, and 5. Right. Okay. So when x is 0, guess what's 0 minus 4? -4. What's the absolute value? -4. +4. What's 4 times 2? 8. What's 8 plus 6? 14. So when x is 0, y is 14. Is that like a y-intercept? Right? Now, look at, okay, maybe I should add a y-axis that went even taller than that. But is that believable? Guys, could this cross at the point 0, 14? I think it looks about right.
Yeah.
Looks about right? Right. Let's try these other ones. What if x is 3? Guys, what's 3 minus 4? -1? What's the absolute value of -1? 1 times 2 is 2 plus 6 is 8. The point 38. So here's the point 3, 3, comma 8. Hey, that's right here. Here's the point 38. It's right on the curve. Okay, let me pause. Let's get this phone call. And we're back. We're back. All right, so let's think about 4. Guys, plug in 4. What's 4 minus 4? 0. This whole thing, 0s plus 6 gives you 6. Okay. So 4. Oh, hey, that was the vertex right there. 4, 6. And then if I plug in 5, 5 minus 4 is 1 times 2 is plus 6 is 8.58 is right here. Bam, there's 0.58. Yeah. You see it's mapping out? So now you have a couple ways to graph this, right? You start with the parent function and go through these transformations. Or you can just come up with a table and just start plotting points until eventually the graph emerges. Right? All right. Let's do these word questions. How about here? I haven't done this one yet today. Let's do biking. You see Rohan here is riding his bike. So one more thing. We're looking back this one. I forgot. Let's do domain and range because we need more practice on those. Let's do domain. Let's do range. Okay. We'll do set builder, and we'll do interval. And same thing for range. Set builder, and interval. Okay. Okay. So guys, what's the domain of this graph in set builder notation? So it'd be curly bracket, and then what? X such that X. Guys, can X be anything? Is the domain everything? Is that element of all reals?
Yep.
And then close curly bracket. Okay. And in terms of interval notation, you would express that how? Open parenthesis.
Negative infinity.
There you go. Negative infinity, comma, infinity, close parenthesis. Okay. So that's if the domain can be anything. Okay. Now the range, not so much. The range is limited. Right? Like could y be equal to 1? Could y equal 1?
Nope.
No, there's nothing down here. Right. Y only starts at what?
6.
6. Yeah, 6 and up. So let's do set builder notation. Let's do open curly bracket. Y such that y is what? Yeah, greater than or equal to 6. Close curly bracket. There you go. What about interval notation? How do you write that? Open bracket, 6, comma,
Infinity.
infinity, close parenthesis. Yeah, there you go. All right, is there any question on domain and range? Okay, so
It's crazy.
all I do is kid riding his bike around. Got Rohan riding his bike at a constant rate from his house and back again. So started his house, he's riding away, he's going back. The distance in miles g of x from his house after x minutes is represented by the function g of x is okay. So we got -1, 6, and x minus 30 in the absolute values, and the whole thing plus 5. Graph the function, determine key features, then interpret key features from the graph in terms of constraints of the context of the situation. Ooh, this sounds exciting. So we got page 50 spiking. So giving us a g of x equals, okay, it's a -1/6, and then times an absolute value bars, we got x minus 30. And the whole thing plus 5 after x minutes. The distance from the top after x. Right. So what does this graph look like, and what does it mean? Right. It's going to tell us something about how far away he is after some time. Because in terms of transformations, the plus 5, you shift the whole thing up 5. What does the minus 30 mean to do?
Right.
Yeah, right 30. Guys, this is right 30. And then -1/6 like flips the whole thing upside down, makes it really shallow. Right. Yeah, slope of 1/6. Yeah, on the positive. Okay. It'd be negated. Okay. So it's going to be upside down v, 30 to the right, and 5 up. So I need to go 30 to the right. Way up here. So okay, then 5 up. 5. Okay, I'm just gonna put 30 way the heck out here. 30 and 5. Like that. Here's x. Here's y or g of x. Okay. And then guys, the slope should be 1/6, and also it's an upside down v. So guys, if I make this an upside down v and have a slope of like up 1/6, where's this gonna up 1/6, right? Well, does that mean that the up 1/6, the slope should take you exactly back to the origin? Like that? Should go exactly through the origin? Because if you start at the origin, you go up 1/6, up 1/6, up 1/6, and you do that 5 times, doesn't that bring you to the point 30, 5? Right, would that be true? The slope would be 1/6. Okay. Now this is an upside down v, so another half of this. Maybe I can just barely fit this at the edge of my paper. I think. I'll sort of try to squeeze it here. Guys, could 60 be basically at the edge of my paper over here? Could be 60. And this could go like this, upside down v. Isn't that exactly what that should look like? Okay. Let's test it with some points. Come up with an XY table. X, Y. I want to test 3 points. Let's see where X is 0, 30, and 60. Because those looks like 3 key points. Bam, bam, bam. Let's see if that's true. Let's plug in 0 for X. Okay, plug in 0 for X. What's 0 minus 30? -30? What's the absolute value of -30? Positive 30 times -1/6 is what? What is 30 divided by -6? -5, right? Then add this 5, what do you get? 0. So the point 0, 0, which does align with this point here. I was thinking it would cross to the origin, and now we confirmed it does. Let's plug in 30. Guys, what's 30 minus 30? 0. And now this bit zeroes out. Plus 5. That's this point right here, like the vertex. 5. Then 60. Guess what's 60 minus 30? That'd be 30 times -1/6. It's -5 plus 5 is 0. Right? Yeah. So we got exactly the right curve. It looks exactly like that. Right. Now, what does this mean? So interpret key features of the graph in terms of constraints in the context of the situation. Right. So I know x is the number of minutes. Is that what it said? Yeah. Number of minutes riding his bike. Okay. G of x is the total distance from the house. Distance from the house. Okay, so I think what's going on is because at times 0, he's 0 distance from his house. So at times 0 distance we're at his house. And then after half an hour, he's how far away from his house?
5 miles.
5 miles. It was miles, right? I think.
I believe so.
Bike at a constant rate, distance. Oh yeah, in miles. Okay. So, all right. Okay, so after 30 minutes, he is 5 miles from his house. Okay. And then, guys, what does he do at the point where he's 5 miles from his house after 30 minutes? Then what does he do?
Go back.
He goes back to his house all the way home. And when does he get home? Yeah, 30 minutes after that. So he's been away from his house for an hour. Okay. So at 1 hour, which is what 60 minutes is, okay, he returns to his house. All right, that was pretty fun. That is our pause point today. Tomorrow we'll do 1-6. Then guys will be getting ready for the quiz on Friday.